Next, I'll be explaining on the manufacturing process selection of the barrel. The translation. The function of the barrel is as a main body for the syringe to insert the medicine. The constraint that we need to apply is the material. The material must be a polymer and thermoplastic in a specific polypropylene (PP). Next, the shape must be 3D hollow, and the estimate mass is about 0.1 to 0.2 gram. Lastly, the constraint is the finishing. It must have a smooth finishing. Furthermore, the objective of the production process is we need to minimize the cost. The free variable for the manufacturing process is process operation condition and choice of the move to the scoring and ranking manufacturing process to get the best manufacturing process to be selected and applied on our product. Implementation of the manufacturing process, we can conclude that the injection molding process should be selected because it ranked the first among the other process. The surface finishing produced are very smooth, which fulfill the constraint. Thus, the labor intensity is lower compared to the other process. Economic batch size that can be manufactured by the injection molding process have a large amount. Lastly, the process really suits our objective to minimize costs based on properties that we can get from the SES EduPack software data.
Assalamualaikum and hi, my name is Siti Norima binti Fauzi. I will explain about material selection for plunger. Students should carefully identify the zero material required for the plunger. Each material selected must meet the properties required to meet the requirement. Students need to compare the pros and cons of a material to determine which material is the best. The design of the plunger needs to be defined. Next, we can see the design requirement of the plunger. Function, objective, constraint, free variable. After that, student can draw a graph of the constraint, focus on the index material for the next step, which is to find a suitable material for the plunger of the strain. For screening, tensile strength and density is an advanced material selection. Advanced selection is to consider all types of material to be used. There are about 100 materials in the tensile strength chart, but only 2 materials were selected and identified as the best materials to produce the plunger. For the commentation, polypropylene took the first place as the best material for the plunger. Compare the polyethylene. Polyethylene is regarded as a touch material because it can deform without breaking. It also very flexible, which makes it easy to mold in different shape and ensure that it can take denificate demand prior to breaking.
Now we will present about production process, the procedure of making syringe plunger. First, the material, which is polypropylene, will heated into liquid state. Next, once the material be heated, and it will go into the mold by using injection molding. Then, once the plunger out of the mold, it will be let to cool down. Finally, the plunger head will be attached to the plunger. Now I will present the manufacturing process selection. In the table state that requirement process for the making of the plunger. The function is the process to able to shape the plunger for the medical syringe. And the constraint, it will be first the maximum component size that the process can handle. Next is the thickness, then good tolerance, and finally relative tooling. And the objective of this is to minimize the cost. For screening, we will choose the process that's suitable in manufacturing the plunger in aspect of mass, thickness, tolerance, and relative tooling. Ranking is to pick a process that satisfies all the requirements in manufacturing the plunger. As in the table, injection molding has been chosen as it scored the highest. Out of the process, injection molding has been chosen because it satisfies all the requirements for the process needed. Next, properties that look into the mass range, thickness, tolerance, and relative tooling. Injection molding has been in the industry for a long time and is not strange in making a product with a low time consuming. Lastly, the application of injection molding makes the assembly process at a low cycle time for mass production.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afizuddin bin Harizam. Okay, today I want to talk about processing parameters. There are 8 processing parameters, which is the function of the syringe, the size of the syringe, the toughness and the use strength of the material that we choose, the motion of the syringe, the thickness of the syringe barrel, the syringe economic, the process that we choose, and the last one is the tolerances. Okay, next we move to the effect of parameters on the product. There are several effects of parameters on the product that we divide into 2, which is material properties and process properties. The first one for material properties is fracture toughness. In this case, we need a tough material that can deform without breaking and also very flexible, which makes it easy to mold in different shape. The second one is tensile strength. To design the syringe, material need to be chosen with the highest tensile strength value that will make the component strong and not easy to break. If we use low tensile, it will cause a failure on the product. The next, economic. Although the syringe is used disposable, but the material should be light so that easy to use. Next, the process properties. The material. The process must be fixed with the chosen material. The injection molding process is used because it suits the requirement state of the material. Next, thickness. The thickness of the syringe increase according to the volume of syringe. The tolerance are pivotal in the manufacturing process because they will determine how well a part will fit in the final piece. Thank you.
Hi, Assalamualaikum. I'm Ashram bin Tajalasa and I'm going to present about quality control and testing, PHA and DIN and ISO stress test. Thermal stress tests are used to see whether a foul expand is stress under stress. This test has 2 formal procedures. The syringe is placed in beaker and then placed in autoclave. Next is DIN and ISO 7459 stress test. Includes temperature shock. A crack occurs when a defect expands in stress during a stress test. Next, pressure test. The blue solution is injected into the defect at a level above the defect. Before putting the plunger in, eliminate any air pockets from the plunger head. Then, using a white glucose cloth, Wipe the syringe exterior around the defect to remove any debris. If the blue solution is visible, the defect is a cracked surface. Lastly, scratch test. A potential fracture is checked to see whether it penetrates the glass. If so, the crack is sealed. A scratch is formed across the fault using a syringe needle. This process is repeated 5 times on the syringe inside and outside. A complete glass fracture occurs when the same result occurs on both the interior and outside of the glass. Defect and countermeasure. Thermal defect. They are also found in the syringe barrel center. Stress crack are not the same as stress crack, even though they are caused by thermal stress. Stress crack. When the syringe barrel is compressed, stress fracture occur at the core. They are classified as significant force because they may affect the syringe integrity. Cone crack. Cone crack with low fatigue strength that develop where the cone meet the shoulder may be detected. Next is countermeasure. Thermal defect. Decreasing the temperature difference or selecting a more suitable lining material in the first place may help avoid from the occurring. Stress crack. It's possible to reduce the frequency of occurrence of the problem by carefully monitoring handling during the production process and optimizing the appropriate parameter. Cone crack. It's important to considerably reduce the occurrence of this problem by optimizing the temperature profile.